Okay, this is a MATLAB short video. All right, what I wanted to do today is look at MATLAB indices and the magic square. All right, so um, if you don't know the command for the magic square, one of the nice commands to know in MATLAB is look for. So I know that magic square would have the word magic in its help page. And so if I can say look for magic, it comes up and tells me the name of the command. So as soon as I see that it's there, there's no command prompt here, so I know it's still looking for other instances of the word magic. So I can hit Control C and exit out of that. All right, so now I can type help magic, and it tells me what a magic square is. A magic square is an n-by-n matrix constructed from the integers, and if you sum the row, column, and diagonals, you get the same answer in all directions. Okay, so I can make a magic square. Let's make a 6x6 magic square. All right, so there we are. So I might be curious, how would I access various elements of the magic square? And for example, how would I check whether the sum of two different columns of the magic square equal the same number? All right, so I can do that by accessing elements of the magic square. All right, so let's take a command that will give me the first column of the magic square. All right, so in MATLAB, if you hit the colon operation, that tells me for this index position, I want all the possibilities. All right, and the first index position in a matrix in MATLAB is the rows. All right, so it's rows by column. The way I remember that is RC cola, row first, then column. All right, so I'm going to take all the rows and the first column, and that would give me this answer. All right, so I might want to know what that sum is, so I can type sum A. Oops, I forgot to close the parentheses, and I get 111. All right, so back to our magic square. Let's check the same thing for the second column. So first of all, let's verify that we're getting the second column. All right, so yes, indeed, there's the second column. If I sum A 2, I get 111. All right, so just one more example. Let's sum the fourth row. Okay, so that would be the 8, 28, 33, 17, 10, 15. If we sum the fourth row, that would be choose the fourth row and all of the columns. And again, that summation is 111. So it looks like the magic square is working. Here's a tricky one though. How would I sum the diagonal? Okay, well, it turns out there's a trick. MATLAB will store a matrix in a certain format, so it's actually numbering the indices starting here at 1 and going down. So 1, 2, 3, 4, 5, 6. 7 would be this entry, 8 would be here, 9 would be here, 10 would be here, 11 would be here, 12 would be here. Okay, so just to test that theory, what is A of 12? It's 36. Okay. Well, if you knew that, then you could make a vector. All right, so we're going to make a vector that starts at 1. And so 1, 2, 3, 4, 5, 6, 7, and then we want 8 here. So we're going to go in steps of 7. 1 plus 7 is 8, all the way out to the length of, well, I know that this has 36 elements in it. Okay. All right, so now let's look at A of n. A of n is 35, 32, 2, 17, 14, 11. So there's the diagonal. Okay, so that was kind of tricky. But if I sum an, I get 111. All right, so the value of this is a couple of things. We learned about the look for command. So if we had some idea of what might show up in the help part of a particular command we're looking for, we can use look for to find the actual help. And then once you find the name of the command, you can say help the command name and get some documentation on how to use the command. Okay, the other thing that we looked at here was accessing elements of an array using the indexing scheme given by MATLAB.